Hello and welcome back to the Space News by SpaceIndustryNews.com. My name is Will. Let's talk about some antimatter gravity experiments that are going on at CERN. And let's talk about some SpaceX Starman Tesla guys that are flying out past Mars right now. That's what we're doing today. And it's all brought to you by Arbor Soap, arborsoap.com, the best soap in the universe. That's right, the best soap ever. So let's talk about some CERN stuff. Let's talk about some antimatter gravity experiments that are happening at CERN, guys. So when you're in high school, you can release two objects of different masses in the absence of friction forces, and they fall down at the same rate in Earth's gravity. But what we don't know, what we haven't learned, because it hasn't been directly measured in experiments, is whether antimatter falls down at the same rate as ordinary matter, or if it might behave differently. Now, there's two new experiments at CERN, Alpha G and G bar, and they've now started their journey towards answering this crazy question. Now, you may be wondering what Alpha G and G bar are. Now, alpha-G, capital Alpha, lowercase g, is very similar to the Alpha experiment, which makes neutral antihydrogen atoms by taking antiprotons from the antiproton decelerator and binding them with positrons. Sorry, this stuff is hard, man. Think about this. Positrons from a sodium-22 source. It's hard to read this stuff. I'm reading this off my other monitor. It's hard to read this stuff, so just kind of bear with me here. And then alpha confines the resulting neutral antihydrogen atoms in a magnetic trap and shines laser light or microwaves onto them to measure their internal structure. The Alpha G experiment has the same type of apparatus for making and trapping anti-atoms, except that it is oriented vertically. And with this vertical setup, researchers can precisely measure the vertical positions at which the antihydrogen atoms annihilate with normal matter once they switch off the trap's magnetic field and the atoms are under the sole influence of gravity. The values of these positions will allow them to measure the effect of gravity on the anti-atoms. Whew, that's a lot of stuff. Okay, so just hold on. We're almost there. Now the G-bar, capital G-B-A-R experiment, also located in the ad hall, takes a different track. It plans to use antiprotons supplied by the Alida deceleration ring and positrons produced by a small linear accelerator to make antihydrogen ions consisting of one antiproton and two positrons. And after trapping the antihydrogen ions and chilling them to an ultra-low temperature, that's about 10 microkelvin, super, super cold, it will use laser light to strip them of one positron, turning them into neutral antiatoms. And at this point, the neutral antiatoms will be released from the trap and allowed to fall from a height of 20 centimeters, during which the researchers will monitor their behavior. Is it going to do something crazy? Is it going to do something spooky? Nobody knows. We've never done this before. And so these guys have worked around the clock, guys and gals, ladies and gentlemen, folks. They worked around the clock, researchers and engineers, and they put together the experiments, Alpha G and G bar, and they've received the first beams of antiprotons, marking the beginning of both experiments. Alpha G began taking a beam on October 30th of this year, and that's after it received the necessary safety approvals. And Alina sent its first beam to G-bar on 20th of July of this year. And since then, the decelerator and G-bar researchers have been trying to perfect the delivery of the beam. They've been fine-tuning this sucker. The Alpha G and G-bar teams are now racing to commission their experiments before CERN's accelerators shut down in a few weeks for a 2-year period of maintenance work. So if they don't get this now, they're going to have to wait 2 whole years to try it again. So cross your fingers, cross your toes, hope everything goes well and they figure it out. Now, Jeffrey Hengst, a spokesperson of the Alpha experiments, says, "We are hoping that we'll get the chance to make the first gravity measurements with antimatter, but it's a race against time." And a G-bar spokesperson says, "The G-bar experiment is using an entirely new apparatus and an anti-proton beam still in its commissioning phase. We hope to produce anti-hydrogen this year and are working towards being ready to measure the gravitational effects on antimatter when the antiprotons are back in 2021. Whew, so these guys are going crazy right now. They don't have much time to do this. They're up against the clock. They got a couple weeks to figure this out. This could be mind-melting. This could be crazy. This could open up so many new doors. This has never been done before. And these folks are working around the clock to try to get this done. This is crunch time. And hopefully, hopefully they figure it out. Hopefully they do enough science in that amount of time and they get the right measurements that they can produce a result that, could possibly change everything. Now, it's discovering any difference between the behavior of antimatter and matter in connection with gravity could point to a quantum theory of gravity and perhaps cast light on why the universe seems to be made of matter rather than antimatter. So this could unlock so many secrets. This is possibly the beginning of so many things, so many achievements in science and engineering to be unlocked. So let's all send them positive vibes because we want to see this stuff too. They got a couple weeks to do this. This was released on the 11th. I'm sorry. When was this released? November 2nd. That was 2 days ago. 11/2. So they got a couple weeks from now, man. So they're up against the clock. Let's just wish them well, and that's all we can do at this point. The Alpha experiment and the G-bar experiment. Hope it goes well, guys and girls, folks. Hope you figure it out. That would be really amazing to unlock some more mysteries of the universe. But it's going to unlock so many more questions. Where is this going to lead? Nobody knows. It's never been done before. So hopefully they figure it out. Now, let's move on to Teslas in space, floating around near Mars. They have a guy, right? They have a mannequin driver in this Tesla, and they shot it into space just as a test to see if they could carry some cargo. And also, it's just cool to launch a car into space. Just think about that. They launched it in February, and it made it beyond the orbit of Mars the 2nd of November. A spokesperson wrote on a tweet, "The Starman's current location, next stop, the restaurant at the end of the universe," along with an orbit diagram. So the diagram shows Earth, Venus, Mercury, the Sun, and on the outer edge, Mars, and even further out than that, in a red circle, Starman. He made it. He made it past Mars. The second sentence of the tweet is a nod to the late, great Douglas Adams. The Restaurant at the End of the Universe is the second novel in Adams' 5-part Hitchhiker's Guide to the Galaxy series. So this little spaceman is flying out there in his Tesla. Man, he's pumped. Oh, man. So he's out there and he's floating around past Mars. But he's not going to stay out there forever. He's in this little Starman guy, a Roadster. He's in this Tesla Roadster. And it's in a heliocentric orbit. So it's going to come back this way. It'll come within a few 100,000 kilometers of our planet in 2091. And that's according to an orbit modeling study. And the authors of that study determined that the car will slam into either Venus or Earth, likely within the next few tens of millions of years. So, I mean, some tens of millions of years. There could be some other organism living on this planet. There's going to be some crazy stuff going on at that point. And this Roadster is going to fly in, be disintegrated by our atmosphere, hopefully, if we still have one by then. You never know. And they give the space car a 6% chance of hitting Earth in the next 1 million years and a 2.5% chance of smacking Venus in that same amount of time. You can track it if you want to look at it online. Go to whereisroadster.com and you can see where this thing is. It's a trip, man. It's a little mannequin. It's a little dummy in a Tesla car flying around in space. I mean, you might as well do it if you can, right? I mean, if you have an extra Tesla laying around because you're Elon Musk and you just happen to have one laying around, you could shoot it into space and crash it into Venus or Earth, in the next few tens of millions of years. I mean, why not, right? Okay, well, that's that. And maybe let's do a little sneaky news here for you too. So some more SpaceX news. The U.S. Air Force and SpaceX are now targeting Falcon Heavy's first launch for a government customer in early 2019. And it was previously expected to launch around November 30th of this year. It's clear that SpaceX's second Falcon Heavy rocket has yet to approach flight readiness, so they're going to hold off a little bit to early 2019. So there's another cool thing on there that's going to be launched with this. There's Light Sail 2 solar sail by the Planetary Society, and they reported on this. They said Light Sail 2 launch pushed to early 2019, and Air Force's official says initial launch capability is being reassessed. Planetary Society Twitter. That's who tweeted that. So that's a little insight into that. Just a small smidgen of extra news you can check out on your own. But it's going to be early 2019. It's not that far from now. And then the Light Sail 2 is going out there by the Planetary Society. All sorts of cool stuff going on with that. That's like the base model for future sailing techniques in space. So instead of a rocket thruster, instead of some sort of a propellant, right? You use the sun to bounce off this sail and push you forward, basically. The sun's rays bounce off this sail, it pushes you forward. So it's unlimited until you run out of the sun's rays, of course. Power for this thing. So you don't need any sort of propellant. It's all out there anyway. We have the sun. So that's what that thing is going to be doing. So hopefully, get some more information at theplanetarysociety.org. And yeah, that's about it for that one. That was the sneaky secondary news we had going on. A couple extra minutes of news there for you guys. And there's going to be way more news this week coming in hot. I've had had my eye on a few things that either got, not really leaked, but I've been told about. There's going to be some pretty cool stuff happening in the next week or two. So stay tuned every morning. I do these podcasts. So make sure to subscribe to it. Make sure, if you can, please leave a review for it. It really helps a lot. And we can make more of these things. The more reviews we get, the more